Hello and welcome to Learn SystemVue in 5 minutes. This is tutorial 15. In this tutorial, we will understand basics of RF system simulator, also known as Spectrasys in SystemVue. Well, the question is, why do we need an RF system simulation? Well, using RF system simulation techniques, engineers determine how many, what type, which parameters, and the order of stages required to meet their own system specification. And these are some of the common symbols we will use during our RF system design. Something like filter, amplifier, circulators, attenuators, power dividers, couplers, and so on. So we will arrange them in a fashion which represents our system block diagram and then perform analysis. The question is, what's so unique in system view? Well, most of the people start, using circuit simulators based on harmonic balance kind of technique for doing their system analysis because they are inherently a nonlinear simulator. However, those circuit simulators are designed for components, and beyond a point, you will face a lot of challenges when you perform a typical system level testing or system level analysis using those. A lot of people use spreadsheets to do a lot of these calculations. Well, programming spreadsheets are very difficult to manage when you have deep considerations about image noise, intermod filtering, handling mismatch effects, and your complex systems may have multiple paths which have to be considered. And by changing one component in between, the whole spreadsheet becomes very complicated in between. So those are not a very efficient use of your engineering time to perform some of these complex simulations. So in summary, traditional tools are not very well suited for analyzing RF system architectures, and these things can be very easily done when you use Spectrasys in system view environment. So let's see how. So we will start our design by creating a new workspace with a blank template. And once you have a blank template, notice you will have a default simulator there, which is basically depicting the data flow. So I'm going to go ahead and delete that. And if needed, we can add our own RF system simulator there. We will do it in a bit. But before that, so all the components which a designer needs to perform his RF design would be available under RF design library palette. In that library, you have various categories. You could go and pick your components from an individual category, or like earlier, we can always do a filtering and then we can filter. You can see you have all the basic needed components in terms of source, power divider, couplers, amplifiers, filters, etc. to implement your RF system. Now, those are the blocks part. Now let's spend a few minutes in understanding what are the typical options in using the RF system simulator, comfortably. So let's add a new analysis in our design, and we could add, any kind of analysis. We talked about it. So in this video, we're talking about RF system analysis. Once we select to add RF system analysis, you can see there are multiple tabs. And using these tabs, we can control how the RF system simulator will work, what parameters it will capture for us in order to get insight into our system design. So once we start working on few sample RF system designs, you will understand the use of each of these parameters, but I will just point out few important ones here. So first, we need to select which design would we like to simulate. Like in the past video, we did that. You can define the dataset name, and remember, dataset is a file which will store all your simulation results. By going to paths, you can add any path in the chain of your system design to perform budget analysis, such as cascaded noise figure, cascaded gain, and so on. We can add up a specific path, define source and destination for the calculation to be enabled. And we can add as many paths as we want in our system. Under calculate, we can define what all parameters I would like simulator to calculate. For example, if you are capturing harmonics or intermods, you can define what's the maximum order you would like to calculate and so on. If you want to compute phase noise and looking at the phase noise data, you can always invoke phase noise and define any offset you want to give emphasis on. In terms of composite spectrum, what all would you like to see in your graph can be managed from here. From options, we can define our thresholds. For example, if you don't want to see spectrum below a certain dBm, for example, I don't care anything below minus 100 dBm, so I can free up some of the memory from simulation so that simulation runs more efficiently and shows you the products or the components which you're really interested on. You can define your frequency selection criteria. You can define your LO operations and the tolerance range, etc. Also in output, once you have the whole system thing planned out, you can also decide at what node would you like to select the data to be available. By default, SystemVue will have data available for each and every node in your system. So we will learn about some of these as we go along. So stay tuned for more video in this series, and thanks for watching this tutorial.